Hello and welcome now to Module 5. Data. Very important topic. We're going to look at multiple dimensions of data in this particular module. So sit back, buckle up.
You mean four-dimensional data?
Yeah, exactly. So the title is, of course, data, files, files, and encryption. And this is where we're at in terms of the day. So we are definitely cruising along, and we're going to consider in this module, first of all, how you should design and implement data caching. That's an interesting statement in itself. We talked about it a little bit earlier, you did, and now we're going to talk a little bit more and get some better definition of what we can do. Then we're going to get into file manipulation, how to save and retrieve files from the system, and then I guess it's important to consider security.
Yeah, we should probably think about it.
Might be sensitive data, so you got to take a look at that. So you're gonna have some fun sharing some of your secrets, but then of course you're not going to share them all, or else they wouldn't be secure. So caching. What do we mean by caching? And in order to answer this question, we have to start talking about what the polar ends of the spectrum are with regard to data. So let's talk first about in-memory data. That would be described in our JavaScript applications as things related to the page, to the scope of functions, variables, objects, etc. Anything that stays in memory. Pretty simple.
And I think one of the elements of in-memory data is that it's super duper fast.
It is fast. I agree with that statement. It's fast. Now what we have to do is understand how long does something remain in memory. So that'll be part of our discussion, because that actually is a contributing factor to, do we need a caching strategy or not? We need a caching strategy because sometimes things don't remain in memory all the time, right? So that's one of the things. All right. Okay, so we have in-memory data. What else? We have expensive data, and we are not suggesting that our cloud service is expensive. What we're suggesting is that it's expensive no matter where you get it. If you have to go across the wires and go grab some data from some yonder place and then bring it back. That is what we mean by expensive. So examples could be services that you call, RESTful calls, or a database call. So those are kind of the two polar opposite ends of the spectrum. If that's all we had, our entire applications would either be lightning fast in memory, and then nothing sticks around, or we'd be going back and forth all the time to some kind of a service or database, but then it'd be possibly slow. So the question, what do you think the question is?
Is this Jeopardy?
Sort of. And the answer is...
What is caching?
That's right. So exactly. He did a very good job. That was very good. So now we're going to look at that middle layer. That's the cached data. What this is, all right, in between expensive data and things that just fly in memory, we have strategies that we can implement that can help us to reduce the cost of keeping data around, yet at the same time make it as fast as possible to use. So, with great power comes great responsibility. We have to use cached data wisely. And so part of that discussion is understanding what the different cache data options are. So we're going to see examples of how you can access files later on. Jeremy's going to talk about how you can access files. We've already seen some examples of what it would be like to make some calls via Azure, and we're going to talk about that a little bit more. And then there's some other type of options. There's options that you could do that are related to the API, such as maybe session state or roaming state or application data of some kind. So when do we know how and when to use all those different types of data options for caching is a key that we're going to be getting into. Other options like IndexedDB. Some are using the new SQLite JS that's available for the Windows 8 applications. That's just another strategy for some immediate calls for data. And local storage mechanisms with HTML5. So with that in mind, we are going to address those and see some examples, but let's talk briefly also about Azure caching. It fits in with our data caching discussion.
Yeah, so Azure caching is extremely helpful, can add tremendous amounts of performance. And what we're talking about here is not so much bringing the storage down to the device, because that's not possible. It's the whole thing, all of Azure is in the cloud, but if your data exists in a database, or if it exists as blob storage or something like that, then it may be significantly far away from you and take some time not only to fetch, but also to aggregate, to localize, to bring it closer to you. And so App Fabric caching exists for us to do some caching even in the cloud, so that if it's not the network call that is the bottleneck, if it's in fact Azure retrieving data and compiling data and bringing data closer to you, then you can use App Fabric, you can use Azure caching and bring that as close to you as possible while still being in the cloud, like on your end of the cloud is where that would be. So that's another caching strategy, is to use Azure caching.
Yeah, I love that, because it's, as Jeremy mentioned, it's just another way to increase the user experience by making something, I guess, easier to fetch, and that's what I like about that particular approach, as opposed to maybe you trying to grab a whole bunch of data and then bring it back down. I love that as far as Azure caching is concerned. Well, I don't want to go into your topic just yet about saving and retrieving files, because I want to show a sneak peek or some details into how CodeShow works. We mentioned earlier that if you wanted to see how some caching techniques happen, take a look at the default.js file in CodeShow. I'm just going to show a couple of those things real quickly. For example, you'll notice at the top of our file, we have acknowledged that there's app data, so application level data. We also have a variable that says, okay, we're also interested in roaming settings. We're also interested in the navigation object, and I want you to see where these can come into play with regard to some caching strategies. Now, if you'll recall, I believe, Jeremy, that you mentioned, hey, how is it that the application kind of knows where to land? How does it know that we were on that page, so to speak, when we left the application? Well, this is a demonstration of how to take advantage of some caching, because I would say the best way to investigate this is to look at it backwards. I think so. Look at it from the perspective of this on checkpoint. This is an event that fires when you're just about to go. See ya. And is there anything you want to do? Well, what we're saying is, yeah, hey, session state, your history is going to equal the nav history. Bye. See you later. Remember, we were talking about in-memory is awesome. We love in-memory data. But what happens when it goes out of memory? This is what's happening. We're about to leave. What do? We want to behave as if the application's always been running, even though it clearly wasn't. So we were able to save that session state history. Then, like I said, I'm working backwards. This is what it was doing as we were leaving. Now, as we're getting into the application, let me expand this out so we can see it in its entirety. We're actually asking this question up here. Hey, is there a history? Is there a history in our session? If there is, then I'm going to make my nav history now equal that. And then I can start to make some decisions as to where we're going to navigate to, whether it's going to be home or if there was a particular location we were at and its state. So this is a really nice example of just one little sliver, one little vertical way to say I need to use some state, in this example, the session state, where we were in the application right before we went to somewhere else. I didn't know if there was any other ones, little tiny ones that don't get into your next topic that have to deal with little examples of using some kind of a caching technique within CodeShow, but that's one I definitely wanted to show. So I'll leave it right there.
Yeah, I know. Maybe some of you are like me and you've done quite a bit of work in ASP.NET. And in ASP.NET, you know that you've got a caching framework. You've got an official place to put your cache, and then you've got kind of official means to invalidate the cache based on time or based on whatever triggers that you need. And there's not a framework for caching that exists in the WinJS framework or in WinRT, and so you've got still have all the same opportunities for caching, and you've got a lot of options for places that you can put that data when it's local, and you have to really think about it. That's why we start talking about the caching design. What is going to be the design of your application as far as caching? Are you going to fetch once at the beginning all the data that the app is going to use? What if the users aren't likely going to use 90% of that data? Then it may be just too expensive, literally, if you're paying for the network time, maybe too expensive to do that full call when the user hasn't even asked for it yet. Usually, unless you're doing something like streaming video, the kinds of information that need to come over the wire are going to fill the screen out, and the user can only look at so much stuff on the screen. So you can be intelligent about how much that screen needs in order for the user to have the information, to feel like knows where he's at. And then you want to do a little bit of look ahead. And for instance, if you're loading a list view, and the list view control does this for you, you can load some of the items next to you they're out of view, but you can get them primed so that when the user does start his swipe, that data then doesn't have to be loaded, but rather it's already been loaded. So you can stay one step, one screen, one record, one call ahead of the user, try to anticipate what it is they're going to need, combine that with some good local caching, and then you can make an app that's responsive, that has all the data that the user needs, but no more.
Very good. So I know that there's going to be an additional slide that I think it just follows from the one right here in the module agenda that says, save and retrieve files from the file system. I think there's one that I wanted to address, if you don't mind, that kind of goes into the topical view of some of the storage options, which do play a part in the session. So if we can have a look at the screen over here, this is it here, the storage options that are available. And so when you think about application level state and specifically the session state object, that's the one we were just looking at. That's the one that said, okay, what is the current state of, kind of like if you were going to take a snapshot of this application at this point in time, what would that session look like? That's what we can save and store in session. However, there are some user settings as well that could be used, and just on a conceptual level, sometimes there's a lot of confusion over what this local settings is versus roaming settings. And so to kind of set that at ease, if you're setting something to local, what you're really saying is that you're going to persist something for that app specifically on that device, and you're good with it just staying just like that. I mean, that's really all it is. In fact, that may be the desired thing you want. If they happen to have multiple devices with Windows 8 installed, and they have your app installed on all devices, it may be desirable that each particular device has its own set of data for that user, even though it's the same user. And that could be, again, what you want. But if you wanted that to be synchronized across all the devices, in other words, perhaps as they're in one application doing something, if they were to pause there, so to speak, and open the application up on the other device, you could theoretically set it up so it is looking like it's in the same spot, and in fact, it's working with the same data. Why? Well, that's what roaming settings can do. Roaming settings can help follow that user along with that app from device to device, and you can choose to save that information. It could be synchronized across these multiple devices so that it kind of feels like no matter where you go, you kind of have that same app experience. But you're in control as the developer to decide which one is better to be used or not. So have you used either one of those in particular, or are you a fan of one versus the other?
Well, I like to say that I like to start with roaming, and the only reason why I would switch to local is if I definitely don't want it to go into the cloud. If there's a device-specific question that you want to ask, it doesn't make any sense for it to go up to roaming. In fact, it would be really confusing for that to appear for the user on a different device. But roaming, don't think of roaming settings and roaming files as directly talking to the cloud. You're still talking to the equivalent of local storage. I mean, it is local. It's just a different folder on the computer. The difference is that it's synchronized. So it's not like you take a performance hit or you're going to have a delay in talking with the roaming settings. It's going to be just as fast as local. So I always start with roaming and then use local if I need to.
I love that you mentioned that. I think what's so fascinating here is that you might think roaming and you're thinking, well, that has to be all centralized somewhere. But it really doesn't. It doesn't need to be centralized. It just needs to be synced, as you said. So that's the key. It's still a local file. It's not like we're putting something in the cloud. We're just simply saying, oh, we're going to make sure that it's synced across. And as a common theme that's been true all day, the user is in control of all things. They can choose not to sync that data. And in that case, it just becomes like local data, just like the local storage option.
Yeah.
Okay, well, the other things I think you're going to start getting into. So
Sure
I just wanted to kind of say, those are some of the options you should be aware of for caching. And now we should turn it over to you.
Awesome. Okay. So storage options are these. And I like to categorize them this way because you can look at how to write a file, read a file, how to write a setting, read a setting, but it's important to know why you do these things and what the different types of data are. And this is what they are. As Michael mentioned, we have application state, and this is really the state of the UI. It's where the user's at. It's the values that they've typed into a form field. That's their page state. That's their application state. And if everything that has to do with application state is stored in that one area, then when it comes time to save your application state, or when it comes time to refresh it after your app is reactivated, it's all in one place, and you're not activating a lot of data that's not necessary. There's also user settings, and user settings are small, relatively small values that describe or properties about the user. These can be stored locally or they can be roamed, but like I said, they're just two different folders, both on the local system. The only difference is that roaming settings go up to the cloud. But these settings are preferences that the user wants to remember. They don't have to be stored into a file. It would be totally possible, but there's just no need to do it that way because you have settings as a provision. Application data and user data tends to be the data that is, it might be bulky. It might contain a significant amount of stuff. The difference between the two is that the user doesn't expect to have control over his application data. Application data is temporary files, local files, roaming files that describe the data that the application needs to work with, but that the user really just expects to see while he's using the application and doesn't expect to see outside of the application. So an example that I would give is, for instance, if you made a task-based app that was helping users to describe tasks and check them off, the user wouldn't expect to go to save and choose a location in his documents library to save out his tasks. Instead, he would just expect that that data is going to be remembered by the app, and the next time he opens the app, he's expecting to see his tasks, right? It's application, it's data that belongs to the application. Now, the user data is a little different. The user is expecting for that data to not be owned by the app. He's expecting to perhaps use the app to modify it, but he wants to own that data. So an example is a JPEG file. A picture that a user has is not something that he only expects to be able to see inside the app, but he wants that to remain in his pictures library so that regardless of what app he chooses today or this moment to edit that picture, he can open it from his pictures library and then later go use a different app to open that picture. So Word files, things like this. These are what users are expecting to save into their library and perhaps be synced up to SkyDrive, available on other devices, available in other apps. That's user data. Now, in order to look at all of those, there's a demo and code show called Storage. And the storage demo lays these out exactly like we have those categories. So the first category is application state. Now I'm going to go ahead and in here I'm going to type something like I'm filling out the form field. I'm filling out my name and I got that far and then I switched away from my app. I switched to something else. I switched to, what app did I switch to? The weather app. I switched to the weather app. Now my app just got suspended.
What?
So it's no longer allowed to use the processor. It's not allowed to do all this stuff. So it's been suspended. My checkpoint has been called. Things have been saved down into session state. And now when I come back to that app, I expect to continue right where I left off, right? Yeah, makes sense. Now let's say I'm right here. And instead of switching away from this app, instead I Alt F4 this app. What happened then? When you Alt F4 an app, that kills it entirely. It terminates that app regardless of whether you want it to or not. I mean, that's what you just asked it to do. So that app has been killed. Now let's launch it again. Now, would you expect to see that data in the field?
No.
Why not?
I just wouldn't.
Okay, well, Michael wouldn't expect to see it there. If you would expect to see it there, let me clear that up for you. It's not there because we did not suspend and lose, or we did not switch away and have it go out of scope. We told it, I'm done. I've typed some stuff in there, but I'm done. Okay? So when you kill it, that application state goes away. So how do we simulate this condition where the system gets suspended and terminated? The answer is you run your app out of Visual Studio. Let's do that. So now instead of just running it from the start screen, give me a second here. Instead of just running that from the start screen, I'm going to run it in the Visual Studio Debugger. Take a little while when the debugger is being hooked up to connect to all that data. It really should have a little spinner at this point. That'd be the best UI. Okay, now if we go to the storage demo and we simulate that we were just, do I know how to spell? I do, ST. I simulate that I'm in the middle of typing in some information and then this app gets suspended and terminated. Now to simulate that, I come over here and I suspend and shut down this app. Boom, that app goes away, it's no longer in my apps list. Now if I run this again, now I would expect to see that data in there. And I'm not sure why that happened, but I don't have time to figure it out. So now I run my app again, and I do expect to see this session state because I ended inadvertently. So now I'm going to jump back into Code Show, go back to the storage example, and oh, it's not there. I think I was supposed to just suspend and not suspend and terminate.
Oh yeah, you were supposed to suspend.
Yeah, okay, that's so right. Anyway, that would restore this state because I added this to my session state and it would bring that back. Okay, next section, user settings. These are properties about the user. Now, the user settings fall in two categories, local and roaming. There's temporary files, but there's not a temporary settings. It's just local and roaming, okay? So I can save some values in here. I'll say local setting, and I'll say roaming setting. And now here, even if I Alt F4 the app, when I run it again and go back to storage, I expect to see those still in there. Those have been saved to disk in the settings file, and I should expect to see them again. Application data, this is saving to file. So let's say I'm going to save content for a temp file. I'm going to save a local file, and it doesn't matter what I type in here. And I'm going to save some roaming data. Let me make this clear that that's not the file name or anything by just saying, nope, this is just data. I'm just saving out some text data, okay? I will save that file, save that file, save that file. Those files have been saved, and when I close out and reopen, go back to storage, there we are. Oh, and actually this looks like it's an old version of my app because I fixed that bug at one point, so I need to go fix that again. Undefined, great. So we've parallel programmed here, paired programmed, and we've done a little bit of debugging, and we've found a bug. User data. User data is, again, the data that the user expects to save out into his documents library and to be able to retrieve regardless of what app he's going to use it for. So we'll just save some user data here and hit save. Now when this happens, I don't want to try to do it programmatically, because programmatically I'm limited. Programmatically I can access my isolated storage, my local settings, my local files, my roaming settings, my roaming files. I could access a IndexedDB database or something like that. But if you give the user control by launching the save file picker, now the user can choose to put that anywhere he wants. So the user can go all the way up to the C drive on the computer, and he can save something right here on the C drive. You would not be able to do that programmatically. You don't have access to the C drive. You have access to the documents library if you request it and the user grants it, but you don't have access to everywhere on the computer. Okay, so right here I can choose that section, call it new document. It's going to be a plain text file, hit save, and it would allow that if I had rights to it on this machine, but I don't, and that's just fine. Okay, so that's the save file picker, and I can cancel that, get back here. Operation was canceled, so it's not going to see that saved, but that's okay. And the next thing I can save is I can save something in Azure Mobile Services. We were looking at this earlier. I can actually save the value in a data table in my Azure Mobile Services instance. So here I'm going to call this Fred Flintstone, the ubiquitous sample record. Close that out. Let's run code show. Let's go to the storage sample and flip over here to Azure Mobile Services, and you can see that this value has been saved. Okay? So those are the various ways to save data. Now, I want to show you the code. So the comments in here indicate what section of the demo that was in, and if we're looking at the application state section, you should recognize this app.session state. The app.session state is exactly where we stored the history, the navigation history, whenever we reached the checkpoint. But in this case, we're hanging our own custom variable. This is one of the fun things about JavaScript, is the ability to add whatever you want right onto an object. And so we can add storage demo on there, not because it existed before, but just because we want to. And in this case, we're asking the question, does it already exist? By using this kind of interesting, relatively terse, and perhaps not readable enough syntax, where we're saying storage demo and then restoring the storage demo. What this means is that if storage demo is null or undefined, then this half of the equation will never run. Instead, it'll skip right down to here. It'll define the on blur. So this means that as soon as the user switches away, then it will add that session state to, it'll add that value, the value of that input box, to the session state, so that it'll be there for the user when they die. So the next section was about user settings, and user settings, remember, are available locally or roaming. And in this case, we want to first restore local settings when we open the demo, and then save them whenever the user blurs that particular screen. So in the on blur, we have a function, and in that function, we basically just go get the input value, and we drop it here under app data, local settings, values, and then we create whatever key we want. So in this case, the term storage demo is going to be the key that we use to save the value in the local settings. Okay? This is just like a big dictionary. You can add whatever values to it you want, and in that value you can drop in there whatever you want. Okay? There is a size limit in the local settings, but you'll discover that when you reach it, like I did. Now the roaming settings are available too, and the only difference is that you access appdata.roaming settings. And remember that whatever you drop in here will be available. So back to the app, under user settings, I added local settings here and roaming settings in the next field. If I were to close this app, start up another device, install Code Show, and load it up, I would see roaming settings. I would not see local settings. Okay? Roaming settings moves, local settings does not. Okay, so now we've got application data. Application data is like the tasks in a task app that we expect to be in the app. The app's going to store it, and we expect the app to restore it. We don't want to have to deal with that data in our own document library. In this case, we're going to store files, and those can be stored in temporary, in local, or in roaming. And the process for all three is just a mirror image. In fact, I should have written a function to handle this because all three are so similar. So I basically just get this temporary folder, and from that folder I call the get file async function and tell it what file I'm looking for. And then in my then, I get to specify file. And so now in that then function, in this function here, in that function I can access file, and it is the file that it just read from the temporary folder. So I can read the text in that file using read text async of the file, and then I chain on another then, and the value or the payload of that promise is contents. So now the last thing I just did here was I read a text file, and notice that I'm returning this. So I read a text file, the next then gets its payload. So here I got the file, and here I get the contents. Now I can load the contents of that file into my input field. Then when I store it, I can pretty much just do the exact opposite. I can create a file, and then inside that file I can use Windows storage, file IO, write text async. Okay? And that's just repeated the same for all of these, so I won't go into those. All right, now the user data is the ability to store in the user's document picker, in the save file picker. Now this one, this code here, I copied out of a sample, and it's pretty robust. It's got some comments in it, and it's got a lot of safety checking around it. So don't think that it's inherently long code. It's only long because it's got all these safety checks and things in it. But there are a few things going on here. We're creating this file save picker. We are setting its default or suggested rather location. We're telling it that we're going to save a text file, giving it a suggested file name, and then going ahead with the pick save file async. When it comes back from that async, we have the location that the user chose, and we can go ahead and write our file into that location. And now we have the right to save in this location in the context of this function because the system knows that the user picked this location and file name. Okay? We didn't do it programmatically necessarily. We spun up the UI and let the user decide where it goes. And then finally, it's slightly off topic, but here's how to store into the Azure mobile services. This involves fetching the table, getting the table, reading it, and then adding the value in for that. But it's not exactly writing to the local file system, but you can certainly look at this code and see how we do that. So that covers the saving and retrieving of files, but now we want to look real quickly at the securing of application data. Now we won't dive in too deeply. This is an enormous subject, but it's a subject that frankly opens up a lot of what-if trails and a lot of conjecture, a lot of subjection. There's just a lot of different ways to do this. If you pick the topic of how do I protect my data, it's a big question with a lot of big answers. And really, if you think about all the use cases that we might want to cover, probably Windows 8 covers it. If you want to talk about creating, requesting, and fetching certificates to validate authenticity, it does that. If you want to talk about hashing and encoding and encrypting data in the various formats, it does that. And I'm going to walk you through just a couple of those and give you an introduction to the namespaces, and then tell you what CodeShow offers you as far as a sample. Now, the namespaces that are pertinent are Windows.security, cryptography, and then cryptography certificates, and then core, and then data protection. Okay? In cryptography, it's a very simple namespace. You basically just have one method called the cryptography buffer that allows you to encode and decode data, and it also allows you to generate random numbers and convert between byte arrays and buffers. So I've got some demonstration of that in CodeShow. Let's go look at that in the UI. This is all under cryptography and encryption right here. So if I open that, you can see that I've got a couple different sections that are roughly named after those namespaces. And in the first one, it's just a log, basically. Do this, done. Do this, done. Do this, done. So we're really going to need to go behind the scenes and look at the code, or in our case, look at the code in Visual Studio in order to see what's going on there. So we'll go ahead and open the cryptography folder. actually called crypto. And in the crypto folder, I've got 3 sections. Now the second section, certificates, has some asynchrony to it. So I'm doing certificates, and then I'm doing do section 3. First, if you look at my architecture, you'll see why I need to do that. I don't want to run section 3 until I run section 2. But let's F12 the first section and jump down to that function and see what we have going on. Now, there's a lot of stuff going on in here, blah, 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 but it's not that big of a deal. You step through each of these and you can see that first we're generating a random number, and here's how. Jumping into that cryptography namespace, accessing the cryptographic buffer, and then generate random number. For any of these, the easiest way to see what's going on, because as you saw, the log basically just tells you done, is to just drop yourself a breakpoint and step through this whole thing. So let's go ahead and run it again. Now here we are in the, actually did we do it? Loading the symbols. Please wait. Shouldn't be long now. Actually, you know why that's so slow? Is because I'm loading all the native symbols and I don't need to. So I should turn that down to, I think I need to turn that down to script only. So let's just go ahead and set our project properties, debugging, and set it to, instead of those, I want to debug in the script only. That's going to make it much faster. That's why I've had that delay and I didn't know how to explain it. Let's run that. Script debugging is much faster. Wow, that was much faster. Okay, now let's load cryptography and encryption. Bam, we're already at that breakpoint. Let's go ahead and step over it, and then let's grab A and add a watch for A. While we're at it, let's go ahead and add a watch for B, and let's add a watch for this buffer. Okay, so I can see the values here. So generating a random number with the cryptography buffer, cryptographic buffer, gives us 43404309. Very random. Doesn't that looks really random, doesn't it?
It does.
I was trying to think of a number, and I would never have guessed that one. It was just too random. Okay, now let's generate random data. We're going to encode to a hex string the generation of random data. This is generate random, not generate random number. And stepping over that one gives us a B that looks like that. So there's some random data, 32 bytes long. Now let's go ahead and decode some base 64 and then recode it into base 64. So there's a base 64 string. A now equals that string. Now let's set our buffer, and buffer is actually an object. So I'll go ahead and expand that object, and you can see that it's really just an iBuffer object. And so all we get in the watch here is the interface. So we just see capacity and length. Not too helpful. And then we hit F10, and now we've got B. So you can see that it has decoded and then re-encoded that base 64 string. Now let's decode a hexadecimal string, just a different encoding style than base 64. Now that's what A equals, a hex string. Set a buffer and then re-encode that using the encode to hex string, and you can see that we've got the same value. Next one, convert a string to various binary data and convert the binary data back to a string. So each time this occurs, you see the buffer and then you see the B return to input string. It's actually input string each time because I used the same one. But you just have a reference here to these various functions and the things that you need to pass them in if that's the kind of binary data that you want to convert. You can also create a buffer from a byte array and create a byte array from a buffer, so going back and forth between a byte array and a buffer. So you can see that work. There's my B. And finally, comparing two buffers. This one is just stating that A and B are going to be exactly equal, and if I compare those, you'll see that B is true. It's true because those two code points are equal, even though we got there with two different routes. All right? So that concludes the cryptography namespace. We also want to look at what's available to us as far as requesting and generating and loading certificates. Now, as you might know, a certificate is a way of saying, most definitely, this is the person that they say they are. Okay? Now, a person can make that claim on their own, or better yet, they can make that claim and include some information about a CA, a certified authority, where the CA, a reputable third party, is saying, yes, we also claim that Jill is Jill, therefore you can trust that this is Jill. Okay? That's what certificates are for. Let's see what we have as far as the use of certificates. So I'll run to this point. Now, under certificates, does everybody understand why we have var that equals this?
Are you even going to try to explain that?
Well, I'll explain it shortly. I'm going to embed in my functions the need to refer to the this, but I mean the this that was in this function scope.
That's correct.
So I localize, I'll use that word, that scope, or that object, that this, and I call it that. And then,
oh boy.
There we are again. This, that, then. In my embedded functions, when I say that, it doesn't mean this. It means that this. Okay? Is that clear?
Oh, yeah.
I think that's clear. You can always tell when we're on the last module or near the last module.
I think the recording folks are going to strike that one from the record.
Oh no, that's gold. That's gold right there. Okay, so in the certificates section, we actually want to create and import certificates, and I'll show this relatively quickly. But basically, we've got Windows Security Cryptography certificates, and we're looking at the certificate request properties, where we're going to set some information about the certificate, and then we're going to call the create request async. This actually does a call to a certificate server, brings back down a certificate, and in this case, we're just going to. This isn't making the call. This is actually just building the certificate. And in this demo, we're basically just showing the request string. Okay, let's see what that looks like. This is in cryptography again.
And you did mean this demo, not that demo.
Right. I did mean this demo.
Just wanted to be clear.
Break out of my debug session there, and we can see here that this is the result. I've never rolled so many times over the same two words. It's pretty amusing. We're looking at the encoded version of a request, of a certificate request.
Impressive.
So it doesn't look like a lot right here, but when you need a certificate, this is golden. This is exactly what you want, right? And the next step is simply to import a PFX certificate. A PFX is just the local file version of a certificate that's you've been delivered or that a service has given you. And in this case, actually, in the demo, we're dealing with this line, which is character. This is a 8,693 character long line. So nice. A very, very long line. Look at how small my scroll bar is. Woo. All right. That's the PFX certificate, and this is the loading of it. If you need it, you need it, right? And there it's there. You just jump into Code Show, load up the cryptography sample, go look at that code, and use it. Finally, is cryptography a dry subject for everybody? I know there are some people that just love cryptography. The kind of people that work at NSA, I think. Am I making that up? Well, it's not me. I'll tell you that. It's not me. I don't love cryptography. But we have to have cryptography. We have to have secure apps. So let's look at cryptography core and what that namespace gives us. This really just gives us a whole bunch of algorithms for doing encryption, signing, and hashing. All right? So in that namespace, let's jump down to the core demo here, the core function. And in the core function, we're going to run through just one sample of taking a value and, in this case, encrypting it. And we're going to use, speaking of the NSA, we're going to use the SHA-1 algorithm. This is the key for the SHA-1 algorithm. So we're going to open an algorithm. You can go look online at the open algorithm and see what all the options are for algorithms that you can choose. And there's a lot of them. But the SHA-1 is the only one that I'm doing here. And as you can see in the demo, you can enter some data, create the SHA-1. The SHA-1 is created. But one thing that's pretty useful is if you go to the, let's go ahead and create a new instance of Visual Studio and use the trick that Michael showed us a little bit earlier, create a new project, and let's see what the core framework has to offer to us for cryptography samples. We'll search for crypto, and we'll get crypto WinRT sample in JavaScript. There it is. And I didn't see this one, but oh, this is just a console app. We're looking for the JavaScript WinRT example. Load that puppy up. And here we go. Let's just run this one and see what it does for us. I just want you to see all the different algorithms that you can choose. So this is a little demo of cryptographic buffer. You can run the sample and you can see some generated data like I was doing. You can also look at some various algorithms. So here's some hash algorithms. There's the MD5. There's the SHA I was interested in. Run that sample, and there it is. You know, frankly, this is a lot of algorithms that I'm not too familiar with. Do you know about the SP800 HMAC SHA-1?
Yes.
You do? Okay. I thought you did. I was setting you up for that one. A lot of stuff in here. So you can see that the cryptography framework in WinRT is rich. If you remember one thing from the cryptography section, remember that there's a lot that WinRT offers you in the area of cryptography.
I thought you were going to say, remember this.
Remember this.
Okay.
Don't remember this. Remember that.
Okay.
All right. So let us wrap up the section on cryptography and encryption. We've looked at all kinds of aspects of data. And we've looked at securing the data, storing it, retrieving it, all kinds of aspects of data. And now we're going to move into the next module. But I tell you what we're going to do. We're just going to take a really quick, like 15-second pause. So
don't go anywhere.
Yeah, if you still have a dial, well, first of all, welcome to the 22nd century or 21st century. 22nd. Welcome to the 22nd century. Get rid of the dial, but also don't touch it because we're going to be back in just a minute. Okay.